All right, good morning, good afternoon, good evening, whatever you're watching this video. Today we're going to begin chapter 7, which is survey sampling and inference. And what we'll cover for today's video is the first section, which is learning about the world through surveys. And this is about how to ensure to collect good data. So we kind of revisit some maybe a familiar topic with the controlled experiment. So in there, if you want to prove a cause and effect relationship, well, you need to be very, very careful and very, very tedious in how you set up your experiment to make sure that your data is not biased. And so today we'll throughout this lecture we'll talk about what are some ways to ensure that, and some common ways that biases occur. Okay, but let's get to it. So 7.1 is about learning about world through surveys. Okay, so before we get in there, we have to talk about some survey terminology. Okay, so the first is a population, and that is a group of objects that we wish to study. Okay, so maybe it could be all community college students that I want to study, and for them I'm looking for maybe the number of hours per week that they work outside of class or something like that. So from this population, I'm interested in a specific numerical value, and we call that a parameter. Okay, so population and parameter always come together. So the parameter here is a numerical value that characterizes some aspect of the population. So these two are always together, right? There's a group of objects or subjects that we wish to study, and from that total population we're interested in some numerical value. Maybe it's like the average of time, average number of times, or the average number of hours per week or something like that spent on homework. Okay, so a census is a survey which every member of the population is measured. So right now, recently the US is getting ready to create their census, and the Trump administration wants to add this question here of, are you a US citizen? Right, so there's much debate going on trying to get this question added to the survey. And I mean, the Trump administration says, well, we should know who's a citizen and who's not, and some people are afraid as far as how they're going to use the data, right? I mean, are they going to find patterns in the data, or maybe groups of clusters of people where they're not US citizens and go and try to deport them or something like that? But it's a very scary question that they're trying to add there, and we'll see if they're able to, but they only have to print like 1.5 billion copies of this survey. So but anyways, I mean, so surveys right now, I mean, it's a big topic right now. Okay, so 4 is a sample. So I mean, a population parameter, like for example, if we want to, sometimes it's impossible to measure or to get responses from every member in the population just because they're too large, or it just costs too much time and too much money to do it. So what we rely on is a sample. So a sample is a collection of people or objects taken from the population of interest. So I'm interested in studying community college students, but I just pick a random sample, say 100 of them, and have them fill out a survey. So we just get a sample. And then a statistic, we've seen this before, is a numerical characteristic of a sample of data. So a lot of things like the sample mean, the sample variance, denoted x bar and s, these are the statistics that we used before already. Okay, but here these are, of course, these statistics are just functions of our data, but with purpose. So usually they're called estimators, and the numbers that result are called estimates. So usually this statistic is used to estimate this parameter. Okay, like maybe this is the sample number of hours worked per week, and this is like the true number of hours worked per week. And so we don't know this quantity, but we want to know if this statistic can shed any light on this quantity here. And of course here our sample is kind of our picture, a snapshot of the population, right? Because it's possible for us to go and get the whole population and survey them. So what we rely on is a good representative sample of the population. Okay, so just to get a big picture, okay, I mean, what we're moving towards is statistical inference, meaning we'll be making decisions based off the data. Okay, given data, can you make a decision? So what we want to be able to do is to know good statistics so we can complete the cycle here. So pretty much we start here. Okay, there's a population. Okay, there's a population, and we want to know about this population, something about them. Okay, we want to know out of this population, right? We want to collect some measure from this population. Okay, so usually this population here, they have, and we want to take a measurement of the population. So we population mean, which is denoted with Greek letter mu, population standard deviation, which is denoted Greek letter sigma, and population proportion, which is the Greek letter pi. But our book doesn't use pi, they just use p, okay, for proportion. Okay, so population mean, and then of course the notation is different here. So we've seen mu and sigma when I introduced the normal distribution, and we're seeing it again here to represent the center and standard deviation of the population. Okay, so these are usually the things that we're after. These are the things that we want to make decisions about. Okay, these are like the true measure of the total population. Okay, but ideally what we do is from the population, we make a random selection. Okay, so we randomly select a sample size, and we have our sample from the population. So we just take a little chunk out of here and put them here. Okay, and so so this is what we actually use in our data. Okay, a sample, and hopefully our sample represents the population, right? We want to have a good sample here. Okay, we have to make sure that our selection is randomness because it'll avoid some bias in our data, but we want this sample just to be representative of the population here. Okay, so from the sample though, what we collect is a statistic or an estimator. We're looking at the sample mean, x bar, which we've seen before, s, the sample standard deviation, which we've seen before, and here they call this the sample proportion, which we'll see in this chapter. Okay, but usually in the book they don't write p, they write a p with a little caret on top, a little hat. So usually we call it p hat. Okay, but given the sample and we take this measurement of the sample mean, standard deviation, can we draw inferences on? Can these shed light on? Can we know more information on these true parameters here? Okay, so that's the goal. We want this whole cycle so we can make a decision, right? We can make a decision from these. We can make a decision about these. Okay, but really every step here is very important. Okay, we need to make sure that we do all we can to avoid bias in our results, because if there's any bias in our results, pretty much these numbers here, they're not accurate. Okay, they're not very good estimators of these, and they're pretty much useless if there's bias. Okay, so if we go back to the helper versus hinderer example, we have these 10-month-olds. You know, can you recognize good and bad behavior, and if so, are you more drawn to the good behavior? So I mean, in the setup here, just as a reminder, we have 10-month-old infants recognize good versus bad behavior, and are the infants more likely to favor the good behavior? Okay, and then we're just saying here, if the research hypothesis is true, then the baby will be more likely to select the helper toy than the hinderer toy. So of course we talked about the methodology here, all these steps that we're doing to avoid bias in our study, right? We really want good numbers that we can rely upon. So we do these things to make sure there's no measurement bias. And then of course our sample size is 16 babies in the study here. Okay, and actually this is going to become we'll revisit this in one of our videos, but that's going to become 10 there. Okay, but anyways, so as far as our population in this example, we have 10-month-old babies in the US. I guess that's the population, right? 10-month-old babies in the US. And our parameter here, it's a proportion, but we'll call it P. This is equal to probability that helper toy is selected, okay? And probability is like a proportion. So here we call it a population proportion for the number of times the helper toy would be selected, okay? So these are my subjects, and this is the numerical quantity that I'm interested in, right? I want to know if it's going to be significantly greater than 50%, right? Okay, now we're hoping our research question is stating that, well, the babies recognize behaviors, therefore they're more likely to select the helper toy. Okay, and then here our sample here is the 16 babies. So one thing to note is, well, how did you collect the 16 babies in your study? Okay, were they randomly selected from the population of 10-month-old babies in the US? And here, I mean, I could go back and check this, but I'm just assuming it's this here, okay, the 10-month-old babies in the US. It could have just been within a state or something like that, but I just put that there. But anyways, so how did they collect these 16 babies in the study, and why only 16, right? I mean, why didn't they do more? But anyways, so I mean, that's our sample, the 16 babies. And so our statistic in here was really the sample proportion. So here we have the notation following the book, which is a p hat. That's usually what they call it, a p hat. Okay, but this is like a little caret on top. Okay, but this p hat was equal to the proportion. So it's the number of babies that selected the helper toy over the total number of babies, and so that gives us 0.875. Cool. So this statistic here, we are using we use the sample proportion p hat to estimate the population proportion p. Okay, so this statistic becomes an estimator because we are using this to estimate this here. Okay, so that becomes an estimate. So you know, is this a good estimator? Why are we using the sample proportion as a measurement for here? What we'll learn is that this is a good estimator for the parameter. Okay, but sample and statistic always come together. Okay, they're always linked together because this statistic comes from the sample, and population and parameter are always linked together because this parameter represents the numeric quantity of the population. Okay, and this estimate is what is used to bridge the gap between statistic and parameter. Okay, from the statistic, can we shed light on this parameter here? Okay, so as far as bias, right? So in the study for the helper versus hinderer, these scientists are really trying their best to make sure that their data represented the research question, right? Because if any mistake was made, then pretty much their whole project would be garbage. So you know, if they didn't do that counterbalancing, really, I mean, their results would be insignificant regardless of what they observed. Okay, but so pretty much what it means is we avoid bias. Okay, so bias, pretty much what bias means is that when something's biased, it says a method is biased if it has a tendency to produce an untrue value. Okay, so pretty much we're talking about the statistics, right? Those statistics are not reliable at all. So so we'll talk about a couple types of bias here. The first one is called the sampling bias, and it results from taking a sample that is not representative of the population. Okay, so for example, here the population, we have 12 females and 4 males. So we have roughly 75% female, 25% male. So when I randomly select, when I select my individuals from here, I'm hoping that my sample would be representative of that. Okay, so we want the sample to be representative. It doesn't have to be perfect, okay, but typically my sample, it should be just it should be sorry about that. So here, I mean, here we in our sample we have 50% female and 50% male, whereas here we had 75% female. So these percentages, I mean, they don't have to match perfectly. Okay, we don't want to force that, because forcing it could make our sample could create a sampling bias, but you know, something like this is pretty far off. Okay, pretty far off, because in this population, I mean, 75% of the population is female, and some topics, depending on what we're asking, they could be associated with gender. Okay, just like how we saw, political party affiliation and willingness to accept refugees. There was association there as far as willingness to accept or not, and so we could see that here. But of course now it's the weight of the population, they're off. Okay, so what are some ways that we can guarantee that we avoid this issue here? But it's just saying, look, your sample size, your sample, you should just check and see if they're representative of the population. Okay. Another type of bias here is called a measurement bias. So in measurement bias, it comes from asking questions that do not produce a true answer. Okay, so we have to be careful in how we set up the survey. So just like in the helper versus hinder example, right? They didn't want any measurement bias. That's why they counterbalance, right? They didn't keep the hinderer toy blue all the time to avoid that babies are just selecting the helper toy because it was blue, and those are just favorite colors for babies or something like that, right? So so we need to think about how we're collecting the data, okay, how we're measuring the data. So one example, which is actually they're measuring the data, is taking sample weights of a type of apple when the scale consistently gives a weight that is 0.2 ounces high. So in this case, the scale is obviously off balance, and it's always going to overestimate the weight of the apple. Okay, so pretty much that's what it means, is that it's biased, because we're going to be overestimating for maybe the mean weight of apples. Okay, so one way to fix this is to make sure we use another scale or fix the one that we're using. Another type of bias, which requires a lot more thought, so you have to be an expert within your field here. But in this example, a principal might want to get an estimate of the number of students who use cell phones in the hallways by using teachers to tally. So the issue here, it says, well, since many students hide their phones when they see a teacher, this may not be an accurate data collection method. Because, I mean, for this school, imagine the teacher, you know, who's possibly an authority figure as well, walking down the hallway. What are students going to do with their phones? Well, they're going to hide their phones. Okay, so if the teacher is walking down the hallway, counting the number of cell phones that are out, he's going to count, but a lot of those phones that should be out are going to be hidden from his or her sight. So and so we're going to be underestimating, right, the number of phones that are used in the hallway, right? So what we could do here to fix it is maybe not send a teacher down, but send, you know, a student, right? Have a student walk down the hallway and record the number to get a true, accurate estimate for the true number of students that are using their phones in the hallway. Okay, but see, we're trying to get good estimators, right? Estimators that are not biased, right? So that's what this is talking about here. We want to have good estimators here, right? So of course, in this example, we'd be underestimating the true number, and in this example, we'd be overestimating. Okay, here it's kind of obvious. Okay, the scale's broken. Well, duh, you know, we're going to have some mixed unreliable numbers, and here it's maybe not so obvious right away, but you really need to think about things that could be make your data biased. Okay. Another type of bias is called the response bias. Okay, so it says the sample may be representative of the population, but it is important to know how many responded to the survey, right? So the ones that responded may not be representative of the population. So it's so we may have we may have selected a sample, a good sample that's representative, and maybe this sample, right? We're asking them to fill out a survey, but not everybody's going to fill out a survey, right? Right. So in this example, it says a restaurant may give each table a customer satisfaction survey with their bill. Right. So at Red Robin, they're really good at this because they have those little kind of tablets on their tables, and then after you can pay through them, and also you can fill out a survey right through that tablet. Okay, but do you always fill out those surveys, right? And here we're just saying, well, generally there are two types of people that respond to these surveys: those that really enjoy the service, or those that hate it. So those whose opinions are somewhere in between are not well represented, right? So I mean, typically if someone gets like really bad service, they're really gonna lean into the survey and put a lot of effort into it, and those that get really good service are also gonna lean into it and do that. But if you just had an okay experience and you're just like too full after your bottomless fries from Red Robin, then you're not too inclined to fill it out. So in these surveys, we need to know who selected the participants. Was it the research, or was it just the people? So we have to ask here. We have to think about in like Red Robin, in that example, I mean, pretty much they're sampling all their customers, right? Or even like in Amazon, like reviews. So you see a lot of 5-star and 1-star reviews, right? 5 stars, the product was awesome. 1 star, it was horrible, and they had a horrible experience. But really, the reviews you want to read are like the 3 stars, right? You really want to read the 3 stars, the ones that were like good and bad. Okay. So in these things, well, how do we fix this? Is that maybe because pretty much they are choosing to be part of the survey, so maybe we should make our process more random, and maybe, I don't know, you can add an incentive. So usually for their surveys, what they do is fill out the survey and enter to win in some sweepstakes, right? Or some kind of lottery where you can win a prize, right? So that kind of encourages people to participate in the survey, and that way we get in reviews from 1 star all the way to 5 star. Okay, so so it says so one thing that's very important is that when reading about a survey, it is important to know what percentage of people who were asked to participate actually did so, and also, so that's called like a response rate, and whether the researchers chose people to participate in the survey, or people themselves choose to participate. So if a large percentage of those chosen to participate refuse to answer questions, or if people themselves choose whether to participate, these conclusions are going to be very suspect, very suspect. So as far as like response rates go, especially like for the census surveys, like the Latino population, they have a very low response rate, and so ideally what they do is they give their responses more weight because they know that they're going to be underrepresented in the data. But there's just a lot of things that people just don't respond to. Okay, so we have to know the response rate there. Okay. Because both of these, what's going to happen is our sample may not reflect the true population. So as far as eliminating bias, okay, we're going to talk about simple random sampling. So there's only one way to collect a sample that has minimal bias and that represents the population, and this is a random sample. So we've seen this random sample before as far as participants in a study, right? We randomly assign them into control and placebo group, and as far as randomness goes, we say, well, humans were terrible at predicting randomness, so we rely on coin tosses or the computer software to help us out there. Okay, but this convenience sample is a sample that is selected out of convenience of the researcher. For example, researcher samples all students in the math center. So if I were just, or if I were trying to do a study on Moorpark College students, and I just sampled all of my students in my statistics course, I mean, it's a convenient sample. It just means you're lazy. Okay, the researcher was lazy in getting the sample, and you want to avoid this method because it's not random at all. Okay, a simple random sample draw subjects from a population at random and with replacement. Okay, so and without replacement. And so what it means at random, it means every subject in my population, they all have a chance of participating in my study, right? And I'm going to randomly select them, right? And they all have the same chance of being selected. So say the classroom is our population, and pretty much I'm going to pick a sample of 5. So how I would do this is I would put all your names in a hat, shuffle them around, and then pick a name. Okay, now once I pick a student's name, I will record it, and I will not replace the name back in the hat. I will just throw it away. So when I go, so then I shuffle the names again, and when I go back, there's only, say, we have 38 students, there's only 37 students to select from. So that's what they mean by without replacement, right? Because if we were to replace the name, it would be possible that I select the same student twice, and I don't want to do that. In practice, we don't do that, right? We didn't usually, each subject represents, a separate individual. Right, so without replacement, it just says once a subject is selected for a sample, the subject cannot be selected again. Okay, so 2 things here: random and without replacement. Okay, so here my randomness generator was just putting the hats and shuffle them around, right? Or you can think about bingo, right? When playing bingo, they juggle everything around, spin all the balls around, and then once they select one, they put it aside. Okay. So real quick, just another visual of this simple random sampling without replacement. So here's my population, right? I have these red and blue marbles here, and they're numbered. So I'm going to shuffle these marbles around, shuffle them around, and then randomly select one. So I select this 5 here, and I place it here. Okay, now I'm going to go select another object for my sample, and when I go back to the population, this 5 is not there. Okay, so that's the without replacement. So with these remaining 9 marbles here, I'm going to shuffle them, juggle them around, and then just randomly select one of these. And so here I get the blue 7. Okay, and I place it into my sample. Then I go again to get my third observation, and in here there's only 8 marbles left, and I shuffle them around, and I randomly select 10 here, and I pull it out and put it here. And then for the last one, with these remaining 7, I shuffle them around, and I go in and select this red 1. Okay, this red 1 here. Okay, so let's see an example of this simple random sampling. I mean, obviously you can put all the names in a hat, but if you have a very large population size, say if it's even 700 or so, we're obviously not going to be juggling all these marbles around. It's going to become quite cumbersome. So we can rely on software to randomly select for us. Okay, so pretty much like if I were to randomly sample Moorpark College students, I would just have a long list of, say, student ID numbers, right, for all 12,000 on an Excel sheet or in StatCrunch, and I would use that to randomly select my sample here. So what I'm going to do here for this last bit is just to show you how we do a simple random sample from a population without replacement from a data set in StatCrunch. So I'm going to go to StatCrunch, and I'm going to open up the superheroes data, and I'm going to use this sample function to sample. So here it says sample, and then I'm going to tell them what do I want to collect from that sample, and my sample size, and then my number of samples. So right now I'm just going to select a sample of 20, a sample size of 20 superheroes from 1. Okay, so let's go here. Let's go look at the data here. Okay, so let me go to Explore. Let me go, I think it's in featured data. Yeah, it's right here. Superheroes. Let's click here. Okay, so real quick, this is just the data set here. So I'm interested, my population is superheroes, and it's from Marvel and DC Comics and some other comics here, right? So I want to observe, that's my population, and from my population, I'm interested in some information on the superheroes. So, you know, there's over 700 of them here. Okay, so we have this distribution down here, all right? So there's just a whole bunch of superheroes here, and so you know, I want to, you know, it doesn't make sense to go and sample the whole population here to do a census, because obviously they live all over the galaxy, right? We have some are human race, some are Ungaran, some are comic entity, some are cyborgs, xenomorph, android, human, vampire, mutant. So I mean, we just don't have the funds to go and do all this intergalactic travel and survey all of them. So I'm going to select a sample here. And I can even look at the graph. Let's look at the graph. Let's do a pie chart with data, and let's look at gender. Okay, let's look at the distribution of gender for this population. So if you see here for the superheroes here, we have roughly 68.8% male, 27.25% female, and 3.95% just not categorized. Okay, so maybe it's non-binary, or they're just you know, they don't know the gender for the specific superhero. Okay, so what I'm going to do is I'm going to collect a random sample here. Okay, so let me see an example. All right, so just to get a feel for this population here, male, female. Okay, and so let me go look at, now let's go look at let's take a look at let me see, let me do data and sample. Okay, so data and then sample. Okay, so here I'm gonna select everything, because I want to, when it selects a superhero, I want all the information here. So that's why I'm just going to take everything with me. So I'm selecting all the columns here, and I want a sample size of, say, 20. Okay, sample size of 20. And then here the sampling options, right? It says sample with replacement, sample all columns. So we're not going to select everything. We don't want with replacement. So by default, StatCrunch is going to sample our population without replacement randomly. So that's what we want. So we don't need to check anything here. And then as far as these values go, we don't need to plug anything yet. This dynamic seeding is just the way it randomly selects, but here we're going to open data, new table. So let's see what we get here. Okay, so let's compute. Okay, so here's my new data set here. Let's see who I got. I got Black Widow, I got Angela, I got Punisher, Aquaman, I got Alfred Penny. Oh, I got Rambo. Oh, cool. All right. Anyways, I got Rambo. I got Wasp. Okay. Ronin. Okay. So Cat second. Okay, so here's my population, and it was randomly selected. Okay, so pretty much what StatCrunch did for us, it got all 700 names, put them in a hat, mixed them around, and selected 20 superheroes. Okay, so one thing to note is, let's look at this graph. Let's look at the pie chart again. Let's look at this distribution of genders. Okay, so let's look at with data, and I want to look at gender here. Okay, here's gender. I want to look at sample. I want to compare the genders. Okay, and you could do you could compare all the other categories if you want. We'll get similar results. Let's see what we get here. Oh, here we go again. So if you look here, this distribution. So this is the distribution of gender for the whole population, right? And now here is the distribution of gender just for this population, for this sample. And if you look here, the percentage of male is about 70%. Female was 30%, and obviously we didn't get other. Okay, but if you look at it compared to here, it was 68% and about 27%. So it's very, very close, very, very close. And so, but if you wanted to get that other category in here, there's other ways of doing that. But maybe they're just mistakes, or maybe it's not important that much to our study. But really here, I mean, this was just by randomly selecting. I didn't do anything, and you see here this pie chart looks very similar to the one that we have here. Okay, so what we're saying is by doing this random sampling, it guarantees that our data is going to represent, more or less, it's going to represent a population. right? So so pretty neat result there. So let's do again. So I mean, every sample of 20 is going to give us a different result, and I just want to show you that here. Let me do this again. Let me do data, and let me get another sample of 20. Okay, so let me do sample again. Okay, and here I'm going to want all the information. Okay, so I'm going to select everything here. Okay. Okay, so I just select all here. So usually I hold the control tab while I click. If you want to select multiple things, usually hold the control and then hold the control down and click these. Okay, so I'm gonna do another sample size of 20, and then I'm gonna open a new table, and then let's compute. All right, so see here, we get a new sample of 20, and you see I'm already getting new superheroes here. Right, I get Captain Ato, Snake Eyes, Shocker, T-1000, I think that's the Terminator, Havoc, who do we get? Spider Woman, Evil Deadpool, thought he was evil already, Blackout, Angel Dust. So you know, we get a brand new, right, brand new 20. Okay, and let's look at this graph again. Okay, let's look at this pie chart. Okay, what data? Okay, and we'll look at gender again. Okay, let's check it out. Boom, look at that. So look at this, is like 75% male, 20% female, and we get roughly 5% of the other category. So if we look here, this was my first sample, my second sample, and then of course the population here, right? So each of my samples, I mean, they represent the population right away, and all we had to do was randomly select. Okay, and it's a pretty neat result. Okay, so I mean, and you can look at, I mean, we can look at other categories as well. You can look at maybe the race, or the hair color, or the weights. You know, you can, and we can perform these summary graphs to verify that our sample is going to represent the population. Okay, so so the cool thing about random sampling is, one, everyone has a chance to participate in the study, and two, by randomly selecting, right, this magic happens that your sample, right, is going to represent your population. Okay, so so I just want to show you that in StatCrunch, and show you how to randomly sample from a population there, and also show you this very neat result as far as what randomly sampling guarantees us here. So what we did here was something called simple random sample without replacement. Okay, all right, but that's all I have for this lecture. I guess you're ready for your follow-up.